All right, everybody, we have a request to do a problem from Winter 21, Test 1, Part 4, questions 5, E, F, and G. And we can't see the question. No, we can't. All right. So we have, don't worry about what it is, a synthetic monosaccharide. It just says it's based on this picture here. And on positions 2, 4, and 5, we have axial hydroxyl groups, OH groups. So we're going to draw a chair. We're going to put on every position except for one, we're going to put the axial and equatorial bonds. You do realize there's no more room for bonds on oxygen, I hope. So don't put a third and fourth bond on oxygen. That's not what oxygen does. But on 2, 3, 4, 5, and 6, I want all the bonds showing, okay? 2, 3, 4, 5, and 6. So we're going to do that. Once again, to be consistent, we like the top right to be number 1. Inside comes past half. And 2, 3, 4, 5, and 6. Axials I'm putting first. Down, up, down, up, down. They follow the carbon angles. Angle down, axial down. All right. And the other chair, don't go top right for the oxygen, go bottom right. That chair looks a little nicer, but they're both okay. They both get full credit. Reminder, put your numbers on. Not mandatory, but it really helps you keep track of where you are in the ring. Axials, up, down, up, down, up. That last one's not very straight up, is it? You know, let me grab the. Oh. I don't know what I did. Never mind. I'm going to erase it. It's not straight up. That's all I'm trying to say. Straight up. There we go. Okay. Equatorials. Let's see. The easy ones are here. Well, this one, it goes left, not to the right. Because if it's to the right, it's not parallel to 4, 5, and 1, 2. And here we go. And this one has to go up and to the right. And 2, down and to the right. There you go. Follows the rules of parallel, doesn't it? Parallel. All right. So now positions 2, 4, and 5. Our first chair is going to be this one. And the other one's going to be the one after you do rotations, following all the rules. Up stays up, down stays down. Axials become equatorials, and equatorials become axials. Look at the previous video if that was too fast. Okay. All right. Carbon 2, 4, and 5 get OHs. Axial. Which of those is axial? The black one. On 4. Also the black one, but on 5, the axial is this black one. So we took care of that. Check, check, check. Has an equatorial hydroxyl on 3. So the green is equatorial. And I'm putting H's on because I forgot earlier. And 6 has to have something, right? Oh, it has a equatorial tert butyl group on position 6. That's the green. There's my chicken foot. Don't forget the H. First chair is done. Second chair, remember, down stays down. So you want to do all the downs? OH, 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 H, and H. That's easy to remember. OH, 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 3 in a row. down, 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 and then H and H. And on the ups, we have H, 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 3 in a row. And then an OH. And then a chicken foot. Butyl. And we got our 2 chairs. We got lots of points now. They're 4 points each, I think. Yeah, we did, I guess that's E. And that's F. Right? And then G, I'm going to circle the first one, and it's not even close. And in this specific test question, normally I'll count up how many groups are axial and how many are equatorial. And the one that has more equatorials wins. That's normally your approach to this question. But there's something about a tert-butyl that some of you read about, because I think you looked at the answer. I hope you looked at the answer key too. A tert-butyl has a double branch, doesn't it? It's got the chain and double branch. That means if you put a tert-butyl axial, these methyls are actually physically touching this H and this H. You can't have groups touching groups. This molecule will not even go to this chair. So if you have any tertiary group, this is true for any tertiary group, this explanation. Any tertiary group cannot go axial. And I need the magic words. Here's the reason why. I need the magic words every time. The bulk causes this negative interaction called the, what is that specific repulsion we're concerned about? 1,3 diaxial repulsion. So you don't need to use those exact words, but something that you acknowledge that too bulky to be axial ever. And I don't care about any of the other groups in this example. That tert-butyl took over. Okay. And I think I covered it. I don't think we have to label axials and equatorials because the question had those in it for us. So the circle was G. And this is a continuation of G. All right. That was a little harsh to be only 2 points. Maybe I would give it 3. Okay. And that's the end of that. So that will be another video segment for you to look at, I hope.